What's up guys, Alvaro here from Particle School, and in this tutorial I'll show you how to create an initial state for the fragments so they stay on the floor on the first frame and then make it interact with rigid body objects and static objects, just like this. So let's begin. I'll create a new file, I'll save this one, yeah, override it. So let's just control click here on the tube. This way we create a tube here, and let's check end caps. Let's increase this radius a bit, something like 2.4, and decrease this height here, something like 0.3. Then I'll press T to transform it, and middle mouse button and drag it up here. This way we put it around here and press R to rotate, and let's rotate it a little bit in this direction. This way it stays just almost touching on the floor. As you can see. Now let's select the tube, and on model, let's shatter it. So select it and shatter it. Now here on chunk center, let's increase the force total count to a lot, like 1,000. You can keep it lower, but like this is fine. So I'll press U to go up here and get to my object, my scene level, and let's make all those fragments a RBD fractured object. This way all the fractures become an RBD object. Just make sure you click on RBD packet, and now it will create this Autodop network. So let's add also a ground plane. This way all these fragments fall on the ground plane. I'll press up arrow key to start my simulation. And nice. And what I want to do is wait until it settles down, or almost settle on the floor, and then keep it like this on the first frame. So I'll set an initial state based on this frame of the simulation. You don't really have to wait until it really settles, because it doesn't really settle. You have to add your RBD, freeze, something to make it settle properly. So let's stop around here. So frame 103. Now to save this frame, just go inside of the Autodop network and all the way down the chain. Let's press L to organize it a bit better. All the way down the chain, we have the output one. So let's add a file here. So press tab and write file. Here's the file node, and add it here. Now, before we do something else, let's save our scene and create a new project. So I'll create a new project. That's very, very important and useful to keep things organized. I want to make it on my Particle School folder, tutorials, Houdini. That's my first Houdini tutorial. I'm so excited. I'm very new to Houdini, but I believe we can keep learning stuff together. So in fact, we just have to select the Houdini folder. We don't have to go inside of it and accept. And now it will create the project path on tutorials Houdini, and we can call it initial state tut, underline, and accept it. Now it will create, as you can see here, a folder, initial state tut, with all the folders we need. We're looking for the sim one. And then let's now save our project, save as, and just click here on job, and it will go to this folder when you click on the job. And let's call it init state tut and accept it. Now here on this file, we will save one of our simulation frame. So make sure you make this node active by clicking here, left clicking here, And here on file, just click on job and it will go to your job folder. And now inside of the sim, let's save the initial state. Just make sure you put the .sim at the end, otherwise it will not save as .sim, and you can put it here, .sim. In this way, it will save only one frame of the simulation and it will keep overriding. If you scroll here the timeline, override the other frame. And you just have to, as you can see, the operation mode is set to no operation, so it didn't save anything here. So just put it on write files right now, and it will write a file here based on the frame we are. If you scroll here like one frame, it will save, it will override the other one, and it will save on top of this one. If you want to save all the frames, you have to put like $sign simulation frame .sim. This way it will save all the frames. Here it will put the simulation frame, in this case 104. But I don't really want it right now. We'll use it later to bake our simulation though. So let's see how it's going. To make sure that you have something here, just check the size of your file. Here's 2 megabytes, a bit more, so it has some information there. And now you just have to put like on no operation and shake this node to disconnect it and even delete it. Let me just show you, like here, it still have the 2.4 KB, but if I connect the output here and I don't change this to no operation, keep it on write file and disconnect it from here, it will override this frame and now it have 1 KB. So it overwrote and I have no information here anymore. So just make sure that you first change the operation mode to no operation, then shake it. Let me just see if it wrote, yeah, 2.4. Then shake it and then delete it because we will not need it anymore. And if we go back to the beginning of simulation, it will, let's just switch on the output again. It will start the simulation all over again. But now we have that one frame saved. And the easiest way to put it as an initial state is here on the auto.dop network. So there's this field here called initial state. So you just have to put your initial state. Let's just click on job to make sure that I'm getting the right initial state. Initial state and accept. Now our initial state is here. And if I press the up arrow key to keep going with the simulation, it will continue with the simulation. And that's fine. But now let's say that I want to add something else to the simulation, like sphere. Control click on it, press T and middle mouse button drag here to around here. And let's make this sphere with the help of the shelf tools. Let's make it an RBD object. So just click here with the sphere selected and then it's gone. If we try to simulate it, we have no sphere here. And that's why, because here on the auto.dop network, it's reading this initial state simulation file, and the simulation file only contains those fragments here and no sphere, so it's ignoring it. So to fix this, just delete everything here and we'll put this initial state somewhere else. So inside of the auto.dop network, let's go all the way to this, to the top here, and check it out. Here we have the static solver chain, and here the rigid body solver chain. So the tube and the sphere are here. And what we want to do is add a file node here, another one, just like that one on the that we did before. But in this case, we want this to read files, not write it. And let's put here our initial state. So just make sure you're getting the right initial state. Yep. And now let's add a switch here to change from this tube to this file here. So I'll click here and tab and add a switch node. And then I'll connect this file here to the switch. I don't know what's going on here. Maybe it's something with the contagion. So yeah, now it's fine. And now check it out. The switch, it will switch from this one to this one. Just that. So if the select input is 0, it will take the tube and it will keep going with the original simulation. If the select input is 1, it will change to the file, which is the initial state. And it will, let's see how it goes. See, the sphere is interacting with the fragments, but it's not dynamic anymore, the fragments, the sphere are. So what we have to do is on the first frame, I want it to get this file simulation, and on the second frame and so on, I want to change the switch to the tube again, so it will get all the properties from the tube and keep propagating it down below. So to do that, you just have to, here on the select input, put a small expression. I think it's an expression, and it's $, simulation frame equals 1. What it does is, if the simulation frame is 1, like in this case, it will change the select input to 1, so the file 1. If it's not 1, it will change the select input to 0, back to 0. So if it's 2, it will change it back to 0. So I just disconnected it. Let's connect it again. And now check it out. If I play the simulation, now my sphere is interacting with the rigid body fragments, as you can see. Let's make this sphere a bit heavier. This way we can see it better. So here on this sphere node inside the auto.network, network, you have the physical properties. Let's put it 10,000 and press the up arrow key to keep going with the simulation. Nice. So now let's say that we have a hand key animated object. So let's go back to the scene level and let's add a torus. I will just hide this ground plane so we can see our torus. It's there. I'll press T to transform it in middle mouse button to drag it around here and drag it. Wait. Around here now. So I want to animate this torus. Let's rotate it a little bit too. I want to put this torus from here to here in something like 2 seconds. So if I scroll my timeline out, I'll have the simulation going. So let's disable it for now. Just uncheck this output here. Okay, no. Let's just select this file node here. I'm not really sure how to deal with this. I'm kind of new to Houdini 2, but now you can drag your timeline. So let's select the torus and press K to create a keyframe here on all of this stuff. Now let's scroll it all the way down to 48 and press T and put it around here and press K again. Now I'll press the I'll switch on the real-time mode here, and I'll decrease also the size of my timeline. Let's put it on 120 and press the up arrow key to see how it goes. Yes, nice. Now let's switch it back on here on the output node, and since we did nothing to these stars, it will never interact with these fragments. So let's make it, when you have a hand key animated object, you just have to make it a static object. Otherwise, if you put it a RBD1, it will fall with the gravity and it will ignore what you did with the animation. So let's just select your torus and click here on static object. Now everything else is gone. And if you play your simulation, the sphere is there, but the initial state is gone. What you have to do is you have two ways of doing this. One is with the static object, static chain here. You just have to put this switch, a copy of this switch right here, and connect the ground plane and the same file one here, and it will work just fine. But a friend, Peter, who showed me how to do all of this stuff, showed me a much simpler way, which is here on the file node. You just check the match by name option, and yeah, it's done. Now, getting back to the object level, I'll press the up arrow key and see how it goes. Yeah, that's nice. But let me just show you something. The torus is not really working as a torus, it's working like a convex hull object. So let's here on the torus, let's change this inside of the torus. Let's here on torus change this radius here. Something a bit like this is fine. And let's simulate it again so you can see that it's not going through this hole. So in order to make it be concave, you just have to go inside Auto network and find your torus. It's right here. And then on collisions, it's bullet data. Change the geometry representation from convex hull to concave. Now it will work as a concave object. Great. And yeah, that's it.